Hi, this video is talking about course selection for honors Trig and Precalc students. So there's kind of two different cases. So current 12th graders, Katie, I think you're the only one. Well, you don't have to do anything because you're graduating, so nothing to worry about for you guys. For the current 11th graders, we have several options. So option one is AP Calculus. To register for this course, you need to have at least a B+ in both semesters of honors Trig and Precalc. Now I realize that at the time of your registering, you haven't gotten your B+ in both semesters. So you may need a teacher override for this. If that's the case, you email me back at the end of the semester once we've kind of got everything in the books. And if you meet those criteria, I'd be happy to kind of grant that. Or if you're close, certainly we can have a conversation and make a decision about what to do then. So that's one. The next course is the IB Math SL course. For this course, you need to have at least a B in both semesters of honors Trig and Precalc. Again, it may end up with some registration issues on this because you haven't completed the honors Trig and Precalc course yet. Again, will be if you need a recommendation at the end of the semester, whatever, to kind of complete that registration, you just let me know and we can figure that out. A third option is math applications and personal finance. And this is a very kind of practical hands-on class dealing with a lot of kinds of skills or problems you'd have to deal with as an actual adult in the real world, particularly in the personal finance half of the course. There's no prereqs for this course, so you can register for that straight away. Worth mentioning that if you're planning on playing an NCAA sport, you may have some eligibility questions if you elect to take this course. So you may want to double check with your counselor before you kind of make that submission or that decision. And I think our last option here is the honors Discrete Math course. While I don't know for sure who's going to be teaching any of these other courses, I do know for a fact that I will be teaching this one. There is a prereq for this course, but it's based on your honors Algebra 3-4 grade, so you need at least a B in honors Algebra 3-4 for both semesters. But let me tell you a little bit about this course. So this course is a really kind of fantastic opportunity if you're somebody that's interested in computer science or computer programming or industrial engineering or just pure mathematics. So when we say the word discrete, what we mean is we're talking about the numbers involved. So in most of your high school classes, if we consider the interval between 0 and 1, there's like infinitely many numbers in between those, right? You have like 0.1, 0.001, etc., 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 right? In a discrete math setting, there's no indivisibility, or the numbers are indivisible. Like you can't break one, like there's no decimals in between things. You have the numbers as their own discrete objects, their own individual things. So really what's so interesting about this is so many of the kinds of problems that a computer can deal with can be described using this kind of discrete mathematics framework. So in this course, we're going to kind of survey a bunch of these different branches of mathematics and look at a little bit, like just a little introduction to some of these different areas. This course will be largely proof-based, but it won't be proof in the way that like you wrote proofs in your geometry class, or even the way that we wrote proofs necessarily in this trigonometry course. A lot of the proof that you'll write will be like descriptive of why you know something works or how you know something works. So you kind of write them as a paragraph, as a narrative, and it's a little less like line by line, theorem by theorem, quoting theorems. So it's a little bit more flexible in that regard, and a little bit closer to what you'd actually write as a as a mathematics major in a course that was kind of proof based as well. Now there certainly will be some problems involved, and as well, where you have to do some computation, but most of the computation will be rather slight. It won't be tremendously tedious in that regard. So some of the things that we'll look at in this course, look at combinatorics, and this is just like ways to count things or methods for counting things. And this is a really important topic involving in statistics and probability. And, certainly if you're interested in like a computer programming situation, like if you're trying to design a computer to do a problem, one viable way to do that is to just brute force and like check every option. Knowing how many options you have to check is certainly an important thing to know before you write that program, because if there's an infinite number of options, that's probably a poor program, because it would never end and it would eventually just kind of crash your computer. We'll talk about algebra and number theory, and when we talk about algebra here, we're not talking about like the algebra we did in high school. What we're talking about is kind of modern algebra, which is looking more at structure than it is like solve for x. But the really neat part about these two topics is that when we look at them together, we'll talk a lot about cryptography. So if you're interested in like digital communications or any of these sort of areas, that's a really important topic. When we talk about cryptography, that's a method for like concealing information across a network. And most of the techniques that we use to kind of disguise our information are built around these kind of discrete mathematics problems. And we'll talk about graph theory. And when we say graph, we're not thinking about like the graph of a function. What we're talking about is like a network. So like you have like a bunch of locations in this network, and then maybe you have some like paths in between these locations. And maybe we're looking for like how many different ways could we traverse the whole network, or what's the fastest way to get from like this point to this point in the network, using the available paths there. So a lot of like really important industrial engineering problems get built around graph theory. When we say industrial engineering, like what we're talking about is like processes, like design a way to, like ship this material to different locations, or design a way to schedule these workers for these different jobs, or design a way to, like how you're going to use these machines to kind of complete this product at the end. So like really important industrial engineering. Again, computer programming here, a lot of like computational problems, computer problems can be rethought of as these kind of graph theory problems. So like, again, if you're interested in these kind of areas, this is a really, really interesting course, and we'll build into these topics, but these are some of the more interesting topics that we'll see in this course. So again, if you have specific questions about things, please let me know. If you're getting an error when trying to register things because you don't make the prereqs, just kind of sit tight and revisit this at the end of the semester, and I'll look at your scores once everything is in, and we can make a decision at that point. Okay? See you later.